Ask me for one. I don't know what's going on. Oh, we're back. We're on. Sorry. Okay. Today we are going to talk about. We're going to finish our talk about the stages, about formal operations, and I just want to remind people. Okay. Wait a minute. I'm trying to get to the right slide here, and I'm messing up. I just want to remind people about operations. Okay, remember, let's go back to the PowerPoint. An operation is a mental action. Is a very dramatic, again, a mental action. Okay? And it's people acting on their environment. So come back to me. So for Piaget, if you remember, okay, he says intelligence is not a thing that you have in your head, but it's the action of thinking about the environment. And as we go along, we become increasingly intelligent. Okay, each stage represents a higher level of intelligence. We become increasingly intelligent because we're able to think about things in a better, more adaptive way. Okay, now last time, let's go to the PowerPoint again. We talked about, thank you, we talked about concrete operations because it's the ability to mentally act in the concrete world. The ability to move up in space. Okay, can you get my picture in the corner there? Is that humanly possible? I don't know, we gotta, okay. The ability to move in space, up and down a hierarchy, et cetera, et cetera. Come back to me if you can. Never mind about my picture. Come back to me. Okay. So in other words, and we showed you someone here who was able to move in space by saying what someone else saw, seeing the world from someone else's perspective. Okay. Today, we're going to talk about formal operations. Formal operations, and then we're going to go on from there. And I'm going to talk a little bit about education. Maybe we'll get a little ahead of schedule because I always get behind in other places. Okay. Piaget gets the term formal operations from the idea of formal propositions. We did this a little last week, but I'm going to do it again. Okay? A formal proposition is something that is given hypothetically and in the abstract. So while concrete operational thinkers, usually children, are able to think logically about the concrete world, they have a very difficult time with hypotheticals. Could be's, would be's, and should be's. Okay? Anybody want to teach adolescents, middle school and high school? Okay. Middle school and high school kids, we have about 3 or 4 people in here. I'm sure there's some people watching it on the tape or on TV, DVDs, whatever you have. We're going to teach middle school. They have 2 ways of telling you they don't understand something. Okay? They really don't understand it. Okay? And it's tough because, you know, when they go around the world, they're pretty logical. They don't think I'm older than my father. They won't ask you, oh, you knew to the person who know Babe Ruth also know George Washington. They won't do things like that. They have a good conception of but they don't have a good, and it's very difficult when you run into them. There's 2 ways that people who are concrete operational thinkers, who are not formal operational thinkers, adolescents often will tell you that they don't understand something. One is, anybody ever work with adolescents? That's stupid. That's the main way. That's stupid. Or I'm bored. This is boring. This is boring. Okay? If anybody's noticed, little kids like Bug Bunny cartoons. 10, 11, 12, 13-year-olds tend to like them less. And then adults get to like them more. I remember my son, who happens to be a professional comic, used to say to me, I couldn't understand when I was 11, 12, why you like Bugs Bunny cartoons so much. Right? He said, now I get it. Because at first they're just silly little cartoons, but they have hidden meanings. They have double entendres, meaning behind the meanings. What they say is not right. The concrete reality, you have to go beyond the concrete reality to know what's going on. I'll give you an example. Okay, sometimes this is done on purpose, and then we'll get into the specifics. How many people could sit and watch an entire show of Sesame Street? Who could do that? You watch Sesame Street, right? Just about everybody's hand is up, okay? How many people could sit and watch an entire show of Mr. Rogers? Really? How many people have this overwhelming urge to smash Mr. Rogers in the face every time you see him? Right? A bunch of people, right? I'll tell you the difference. Hello, boys and girls. How are you? Look, I'm taking off my shoe. I'm taking off the other shoe. Police! The only thing about Mr. Rogers' stuff is very, very good, by the way. I'll tell you. But what is a beauty wood? It's a beautiful day in the neighborhood. A beautiful day in this beauty wood. What's a beauty wood? Would you be mine? The difference is, one of my professors was one of the brains behind Sesame Street. And he said, we had to decide whether to go the Mr. Rogers way or not. Mr. Rogers is talking right at the kids. Pre-operational kids and early concrete operational kids. He's talking to them, and if you're an adult and he bores you to death and you think he's foolish, go away. He doesn't care, right? That's what he's doing. Mr. Rogers is gone now, he passed away, but his stuff is still running. It's very good stuff for them. If you know something about child development, it's really good stuff. Sesame Street, on purpose, plays to the adults with hidden meanings and double stuff, like the Cookie Monster. Cookies! I know some kids are terrified of the Cookie Monster, by the people, right? And the count. I'm going to count now, right? He's playing games. He's appealing to adult humor. He said, we decided to do that on purpose, so the adults, just about everybody here said I could watch Sesame Street. There was even a follow-up to Sesame Street, most of you probably don't remember, called The Electric Company. It's The Electric Company. Some of you probably watched it, huh? The Electric Company was after Sesame Street. Morgan Freeman, if you remember, the actor Morgan Freeman, was one of the main characters on The Electric Company. And he's always winking at the camera and making gestures with his face. I mean, they picked a guy like that who was a really, really a good actor. Mr. Rogers not a good actor. Morgan Freeman, they picked a professional actor on purpose because they wanted, because when he winks, he's winking at the adults who are watching. Okay? And so this idea of hidden meaning and double meaning and meanings behind the meanings, all that comes from formal operations. Let's go, and I'll show it to you as we develop this. Okay, let's go to the overhead. Thank you, did it already, the PowerPoint. Piaget calls formal operations intelligence operations on operations. If you're wondering where self-regulatory mechanisms came from, the information processing people came up, you're thinking about your thoughts, right? Self-regulating, well, Piaget had figured it out 50 years or 60 years earlier. It's thinking about your thoughts. It's able to think about thoughts, not just about concrete reality. Let me make something up, okay? Okay? At this stage, people are able to reason logically about hypothetical possibilities and about other than real situations. Their logical reasoning is no longer confined to their actual concrete world. Okay, come back to me if you can. Okay, now, okay, I'll give you an example, okay? My cousin. There was a cousin by marriage, but sorry. If you want to do a short doctoral dissertation, do it in theoretical mathematics. I was a doctoral student, he finished, and he said, here, you want to see my, actually I was just going to be a doctoral student. He said, here, you want to see my doctoral dissertation? It was 2 paragraphs, or maybe a page, of incomprehensible English, and then about 11, 12 pages of squiggles, right? It's, mathematical notation. I said, Eugene, this is very brilliant, but tell me, what is it? So he said to me, it's the mathematical formula for turning a hollow ball, like a tennis ball, inside out without cutting it. So I thought for a minute. Right, you're going to turn it inside out, you're not going to cut it. I said, Dean, I don't think you can do that. He looked at me like I, walked on his white rug with something I got in the bottom of my shoes, right? This look of disdain. He says, well, of course you can't do it in the real world. That's the whole point of a doctoral dissertation. I invented a hypothetical mathematical world where it can be done. I said, oh, now I get it. It's wonderful. I said, it's going to have great use for who knows. People laughed at Boolean geometry too, and then Einstein used it. That was the point. He invented a hypothetical mathematical world. Fascinating, huh? Who knows? But that's what he was up to. Okay? So let's go back to the PowerPoint. What we have here is the individual is able to apply operations, that is to reason logically about, hypothetical abstract worlds, to use hypothetical other than concrete world logic to reason logically about formal propositions, thus the name. Okay? So if I tell you, come back to me, if I tell you, tell me your name, sits in the back, and he's going to go, Amir. Amir is a banana. Okay? All bananas are pink with purple polka dots. What can you tell me about Amir? He's pink with purple polka dots, right? One time, I did this in this class. It was the master's class, and it was someone had brought her 11-year-old nephew. I had somebody sitting in front, and whoever she was, I said, whatever her name is, let's pretend it was Sue. I said, Sue is a cat. All cats are blue. What can you tell me about Sue? He looks over. He's 11, right? He said, she has a white sweatshirt on. That's what he said, right? So I said to him, what about, he said, she's not a cat and cats are not blue. End of the story. That's stupid. That's stupid. Get it? One day, did we talk about Carl Sandburg's poem? The fog crept in on little cat's feet. Isn't that a great poem? That's the whole poem. Anybody ever see the fog roll in? Anybody live near a river or near anything when the fog rolls in off the river? Fog rolls in off the East River shore. You know that song? Like a shroud it covers Bleecker Street. You know who Simon and Garfunkel are? That's a Simon and Garfunkel song. I used to live near the East River, and that's true. Get up in the morning and the fog just rolls in, softly, softly rolls in. No charge for concerts, don't worry, I told you that already. Okay? So, it's a beautiful metaphor. So I'm testing this kid. This was a kid with problems. He was in a hospital for kids with problems, and his outside therapist asked me to go test his reasoning. I think he was 13. So I said, what do you think of that poem? He said, it's awful. I said, why? He said, it's stupid. I said, why is it stupid? He said, fog doesn't have feet. Concrete. Okay? So the following abilities, let's go back to the PowerPoint. The following abilities, you need to have formal operational reasoning before you can intelligently do the following. Isolate a variable. Generate combinations and permutations. Understand ratios. Consider hypothetical possibilities. Understand metaphors, etc. Okay, so come to me and I'll give you an example, okay? We're going to take a little vote now. You have to vote, okay? I have a pendulum. Here's the pendulum, and I want to test, if you know, just be quiet, just vote. And I want to test the period of the pendulum. How many times it goes up and back, say, in 15 seconds, right? 1, 2, 3. How many times? 4, 5, right? You got it. That's and then, or 1, 2, 3. Okay? And what I do is I give you the pendulum. The pendulum has a string, and the string is a hook on the bottom. And you can put weights on the hook. The string also has a little lever on it, or you can pull it a little lever so that you can raise and lower the string. And I tell you, you can drop the string from whatever height you want, higher or lower, or you can drop it or you can shove it. You can give it a push. So we're going to take a vote now about which of those things make a difference, see if you know. How many people think that the weight on the bottom makes a difference, whether it's a lightweight or heavier weight? Who thinks that that'll make a difference about how the period of the pendulum? Raise your hand. Who thinks the length of the string makes a difference? Who thinks, it could be more than one. Who thinks, right, let's start again. You can vote for all of them or all of them. One of them, I'll tell you, at least one of them is right. At least one of them is right. Who thinks that the weight makes a difference? Okay, we got about half the people in here. Who thinks that the length of the string makes a difference? A little more than half. Who thinks whether I hold it high and let it go, whether I hold it low, right? Here's the thing, here's the stick that is connected, whether I hold it way up here or just right here, makes a difference, where I drop it from. And who thinks whether I shove it or just drop it makes a difference? People. Who knows? The answer is just the length of the string. Okay? If I hold it up high, it'll go 1, 2, 3, 4. And if I take the same length of string and hold it low, it'll go 1, 2, 3, 4. That's the only thing. That's not quite right. I told you I had to work with a physicist once. He said, well, that's not exactly right. The gravity makes a difference, and if you just have the string and the friction, there's all kinds of stuff. But that's basically how it works, just the length of the string. Now, unlike, you didn't know, unlike concrete operations, which give you the answers, you know that the distance from Hoopamadoop to Poopamadoop is the same as the distance from Poopamadoop to Hoopamadoop. You don't know where the places are, but there's, right? Right? You know very well that the horse that won a horse race in 1897 is gone. It's dead now, right? You know that very well. Okay? You know very well that the person sitting next to you got out of bed in the morning before he or she walked out the door. Okay, what do you think? Formal operations doesn't give you the answer. A lot of you got the answer wrong. But what formal operations does is give you the ability to make up hypothetical situations. So you're going to hypothetically posit, making any sort of a scientific speculation is positing a hypothetical possibility. You could say, well, it could be just the weight. So I'll keep everything else the same. You're making all the possibilities. And I'll change the weight at the bottom. It could be the string. I'll keep all the other things the same and get the string, right? Sophisticated people say, well, wait, let me take them in combinations. It's like, but you can make up all the different, right? You can keep so you can say, I'll keep this and this and this the same and test this. Then I'll keep this and this and this the same and test this. This is, right? You're putting out all the hypothetical possibilities. I once saw somebody try to teach that to kindergartners. It was a UNESCO program out of the UN. What a god-awful mess. In the end, you just give the kid the answer, right? But even concrete, for fifth graders, it's very difficult. Okay? Hypothetical possibilities. I'll show you another one. Let's go to the overhead, the tablet. Okay? Piaget has an experiment. This won't, right, wait 1 minute. Let me give it a shot here. There we go. He has an experiment where he that's good. Where he has four glasses of water, right? 4 glasses, not of water. They're colorless, odorless liquids in all of these glasses, right? And there's, okay, and they are labeled, not surprisingly, 1, 2, 3, and 4, okay? And there's a dropper in each one of them, okay? And you can take the liquid out. And over here is another one called, I don't know how you do this. Let me do this here. Okay, it's a different shape container. The glass blower had too much to drink the night before. Wait a minute, there we go. It's another container with a different shape. It also has a liquid and a colorless, odorless liquid in it, and it's labeled G. I don't know why Piaget labeled it G. Must be some French word, and everybody does it forever after that. You walk into the room, and there are a whole bunch of small containers sitting there, right? Okay, and in two of these containers is colorless, odorless liquids, okay? You take some G, you put it in here, and you get nothing. You take some G and you put it in here, and it turns yellow. You can't read that, can you? It turns yellow. There we go, in a yellow box. Okay? So come back to me, and so you say to the kid, okay, you tell me what you have to do in order to turn it yellow. All the liquids in here, I took the liquids in those two little glasses, I took from, here, come back to the tablet if you can. The liquids in here and in here, I took from these liquids here. You tell me what you have to do to turn yellow. Okay? Now, pre-operational kids, it's magic. It's just, I don't know, throw something together. Concrete operational kid realizes, concrete operational kid realizes that you've got to have the G, because he saw you put it in. So he did, yeah, he saw you put it in. Okay? So let's go and let's see what it could be. Here's what a concrete operational kid typically says. Look at that. They try one and 2 plus G. What? No. Let's try this again. They try G in 1, then they try G in 2, then they try G in 3, then they try G in 4. That's it. That's what they can do. Oh, by the way, I'll just tell you that doesn't work. Okay. And when you say to them, well, what about combinations? Come back to me. So what about combinations? They go, huh? Huh? What do you mean combinations? Okay, so somebody here generate for me, let's go back to the tablet, all the combinations. Let's do combinations of G and 2. Who wants to do it? Who wants to do it? David, do it. You got a microphone?
No.
Come over here and do it. You don't want to do it? You can do it. Come over here so you have a microphone. There we go. He's mad at me. I don't care. Okay. Go ahead.
Combinations of what?
Combinations of 2 plus G. G plus 1 plus 2. Go ahead. You get what I'm telling you?
No.
In other words, 1, 2, and 3, and 4 alone don't work. So I want combinations of 2. You got it?
No. I don't.
G1 and 2, G1 and 3. Go ahead. Give me all the possible combinations of 2.
8.
Yeah, you got this formula. Don't do that. You got it? Huh? Help him out. Go ahead. Tell us. Do it for him so he sees what we mean. That'll do the 3.
G1 plus 4.
Wait. G plus 1 plus 4. 1, 2, 1, 3. Okay.
G plus 2 plus 1. No, we already did that one.
Yeah.
G plus 2 plus 3.
That would be permutations, but we just want combinations.
Right.
Okay.
G plus 2 plus 4. G plus 3 plus 4. And I think that's it.
That's it. Okay, Debbie, you got what she's doing?
I think so.
Okay. All right. Remember your name again?
Colin.
Colleen. Go ahead. Do the rest, Colleen. What the hell? Do combinations of 3.
Of 3. All right. G plus 1 plus 2 plus 3.
So you have to have G because you saw that I put the G in.
Yeah.
Okay, go ahead.
G plus 1 plus 3 plus 4.
Uh-huh.
G plus 2 plus 3 plus 4.
Uh-huh.
G plus 3.
No.
Is that it?
No, it's one more.
G
And there's one more, of course.
2 plus 3 plus 4.
50. Okay, that's all the possible combinations. Okay, you got it? Now the way it's usually set up, is that this is the answer. Okay, that's the answer. It's usually set up. Whoops. Wait a minute. What happened? What's going on here? Wait a minute. Let me do it this way. It's usually set up so that it's 1 and 3. Okay, and 2 is water. Okay, so it's set up so that it's G1 and 3, and G1, 2, and 3 will also work. 4, okay, 4 stops the chemical reaction. It's precipitating an iodide. If anybody's interested afterwards, I'll explain it to you. 4 stops the chemical reaction. Okay? You want to go back? You can go back if you want.
Oh, I'm cool here.
You're cool there? Okay, good. Okay. So, by the way, I got to tell you something else. He knows how to do this. I know he knows how to do this. You got to be careful about people freaking out on a task. You got it now, right?
Still probably don't have it.
Yeah, yeah.
My mind was completely
Push it down, push it down, push it down.
My mind was completely somewhere else.
Yeah, that's right. But interestingly enough, Piaget will tell you when you're confronted with a task that suddenly hits you, your first instinct is to go to concrete operations. From the first second that he didn't quite understand what I meant, I could see he zoned out. Okay? I could see it. So you have to be careful because it's very easy to zone out here, particularly in stuff that is not familiar to you. The first time somebody showed me, I know I'm formula operations because I can do this. First time somebody showed me a pro football playbook, I didn't understand one thing about it. Nothing. Okay, but we'll get to that. So the point is, so what happens here is that these are all hypothetical possibilities. These are all hypotheticals. These are all could-bes and would-bes and should-bes. Okay, and then what you have to do, come back to me, is you have to take all the hypothetical possibilities, 15 hypothetical possibilities, and then test them one at a time. You've made 15 theoretical possibilities, and you're testing which one actually applies to the concrete world. So let me give you a few examples of kids I've seen. Excuse me. First kid comes in, he says, oh, okay, and you have a whole bunch of little cups there that the kids can use. So the kid takes a small cup, he puts in G and he puts in 1. Didn't work. Then he puts in G and he puts in 2. I said, wait a minute, don't you want a new cup? He's about to do it. He said, no. He said, I don't like to waste cups. I'll do it in here. I said, okay. Then he puts in G and puts in 3, and it works because he's got 1, 2, and 3 in there, right? He's got 1 and 3 plus the water. He said, oh, that's it, it's G and 3. I said, but 1 and 2 are already in there. He said, I know, I tried those, they don't work. This was a kid, I gave him concrete operational tasks, he'd laughing at me. Ah, what are you talking about? Of course it's the same amount, of course they weigh the same. It's ridiculous. I said, wait a minute. I said, well, what if they work together? He said, huh? What if it's a combination? He said, what? I said, no, I tried 1 and 2 and 3. I said, do me a favor. Take another glass and put in G and 3 and see what happens. Puts in G and 3, of course, nothing happened. He said, this is stupid, and walked out of the room on me. Just picked up and left. I didn't, you know. Another little girl I'm working with, and she does the same thing, G and 1. She's taking separate classes. That doesn't work. G and 2, that doesn't work. G and 3, that doesn't work. G and 4. She said, oh, nothing works. I said, wait a minute. What about combinations? She goes, what? I said, well, what about stuff together? Like G and 1 and 3, G and 2 and 4, G and 2. She said, oh, yeah. She said, I guess that you could try that. So you want to write down what you're going to try? He said, okay. And I remember the only thing that surprised me she could write down was G, 1, 2, and 4. It's the only thing she could write down. She said, I don't know. I said, well, try it. So she's throwing this in. She's throwing that. She said, finally, just by dumb luck, she hit yellow. She said, I got it. I said, you remember what's in there? She said, no. And please don't make me do it again, right? She just, too painful. She couldn't figure it out. combinations and permutations. Sometimes you're lucky. You know about putting on boxing things at the dog track? I'll take all the combinations off one. I'll take 1 and 2, 1 and 3 for quinellas or exactas. You know what a quinella is? Go ahead, tell us what a quinella is.
Quinella is when you pick the winner and the second place without, I mean, it doesn't matter in which order they run.
That's right.
The first two.
So if you pick dog 5 and 7, if 5 finishes first and 7 finishes second, or 7 finishes 5, so okay, then you have an exactly, you have to pick the first two. My wife is going to pick a box, right? What are the combinations with this dog? Anyway, she made the wrong bet. She picks a trifecta by mistake. These 3 dogs have to come in order. And they did. So instead of winning $12, she won $118 on a $2 bet. So I don't know. Maybe it was a 1, I don't remember. So it was, but it was okay, but she knew what she was doing. She just told the person the wrong thing. All combinations, generations, you can see how isolating a variable, getting combinations, ratios. Let me show you ratios, okay? Okay, you take this is Mr. Big, and this is Mr. Little. Okay?
Floyd's not doing Floyd yet.
That's Mr. Little. Mr. Big and Mr. Little, okay? Oh, I see. All right, time for Freud. Okay, and you have come to me, and you have strings. Come to put the picture. Can you get my picture in the corner? Is that possible? To go on the other thing and get my picture in the corner? Can you do that today? I know sometimes the technology works, sometimes it doesn't. Okay, and what you do, you're right, by Freud would say I did that on purpose. Okay, and what you do, thanks, is what we're going to measure is. What we have is paper clips. We have chains of big paper clips and chains of little paper clips. So I find that Mr. Big is, right, when I measure how many small paper clips he is, he's 8 small ones and 6 big ones. And 6 big ones, right? You understand what I'm saying? If I stretch the paper clips, I reset it takes 8 small paper clips to measure them and 6 big ones. Now I have Mr. Little, and I say he's 4 small ones. So how many big ones is he? Kid says 2. Difference is 2. You get it? They can't do ratios. If this were, right, 100 big ones, all right, and 150 small ones, if I had one that was 200 big ones, they would tell me it was 250 small ones. Whoops, what did I do? 250, whoops, let me get this right here. 250, I don't know what I'm doing. 200, what's going on here? What did I do? Oh, I see. That's a good idea. Click on the pen, and then click on the blank. Thank you very much. 250 small ones. The difference is 50. Rather than saying, oh no, it has to be 300. See what I'm saying? All right, come back to me. They're thinking in concrete units rather than abstractions. I will tell you a story that I still remember from when I was 10 years old. Our cousin Linda lived 2 blocks away around the corner. Okay, I lived 3 houses or 5 houses from the end. She lived 2 houses from the end. Very short walk. Fortunately for me, she had a brother who was just about my age, a little bit younger. So she would torture him. But one day he must have seen her coming and run out of the house. All of a sudden, I'm watching television. I got to tell you, when I was a kid, I loved television. I just loved it. I went through it again when I first got cable, but now, if there isn't a Law & Order rerun, I'm not too interested. Okay? I love television. I would watch television day and night. So I'm watching them. She bursts in. I think I was in 5th grade. She's in 8th grade or 5th and 7th. Something like that. She said, fifth and eighth, I think. She said, want to see what we did in math class today? I said, no. I want to watch television. Okay, let me show you. She said, well, cousin, what am I going to do? So she's solving for x. It's pre-algebra. X equals this. Da, 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 da. She said, you got it? No, I didn't understand. I didn't understand. Finally, she says to me, we go, and she said, okay, x equals 5. You got it? I just wanted to get rid of her. I said, yes, I understand. Now let me watch television. You want to do another one? I said, no, I want to watch television. Good, we'll do another one. So we go through it, and I remember, I just know that. Finally, she says, x equals 9. You understand? I remember I said, what are you talking about? You just told me x equals 5. All of a sudden, I came back into action. She said, no, sometimes x can be 5 and sometimes it can be 9. In other words, it's a hypothetical abstraction. I said, no, that can't be. X has to be something. It has to either be 5 or either be 9. And to show you how upset I was, I walked out of the room. Those were the days of one black and white TV. I walked out on the television. I was so angry. For me, that was a big deal, right? I just couldn't get it. It's a hypothetical abstraction. How can it be? I once tried that thing with the notes and the octaves. That's why it fascinates kids. How can you play completely different notes and get the same tune? You know, bing, 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 bing. How can you do that? How can it be? I remember somebody showed me the first time, played a song all on the white keys, must have been in C, and then played it mostly on the black keys. What scale is mostly on the black keys? Push it down. Say it in English. It's one of the flats or sharp scales. It's got 5 notes on the black keys. Which? Scale of 7 is normal. Wait, push it down, push it down. Which key is it? Do you remember? Key. Push it down. D sharp, there you go, C sharp, D sharp, right? And I remember looking, how can you get the same tune? It's mostly, there are 5 black keys right on the scale out of the 7. How can you get the same tune from the black keys as on the white keys? I'll tell you what song is almost all on the black keys. I can't remember. It's a. If you play it in one, I can't. Oh, it stunned me. How can it be? Because I couldn't understand the hypotheticals of. Anyway, language also, yeah.
Yes, I just want to say, why do they have the black keys for anyways? I mean, what?
For sharps and flats.
Oh, you don't understand. I'll explain to you. Okay.
He'll explain it to you later.
Thank you.
He'll explain it to you later. Go ahead, you want to tell us quickly? Push it down, push it down.
Okay. Octave is from A to A, or B to B, or G to G. Octave, distance.
It's an octave, right?
Octave.
8 notes.
You have only 7 notes. When you go 1, 2, 3, 4, 5, 6, 7, next will be repeat the first one.
Da 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 da. That second one, that da, was the same note as the first da, just an octave higher.
The distance between each note is 1 step.
1 step.
It's kind of big 1 step. To make half
Well, are you pushing it down?
To make half step, they put black key, became half steps, not full steps, half, half,
Okay.
and 2 half, make 1.
Right. Western music is written with an octave with 8 keys, okay? And those are the 8 steps, but we have half steps in certain places. That's how Western music works. If you take the same mathematical combination, the first, the third, first, second, third, and then first note of any key, it'll give you the same tune. Dum 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 dum. Right? You understand what I'm saying? It'll give you the same tune if you take the same mathematical combinations. I remember how difficult that was for me to understand when I was a kid. And of course, especially when you're hitting different keys, because you can start a key at a different half step, and then you're going to get different, completely different notes in the, right? And if you listen to principles of harmony, principles of the, what is it, the something of 5, the circle of 5s, principle of what is harmonious and what's the word of what's the opposite of harmony?
Powerful.
Yeah, powerful. But there's another one. No, it grates on your ears. It's the word will come to me. All those are mathematical principles that require abstractions, and it's difficult to understand. It's difficult to understand. And that's why you'll see little kids who play the violin, if you ask them for theories about music, it's tough for them. They get it, quote unquote, instinctively. They can play it, they can do it. But the philosophy behind music, that's orchestrating and all that stuff. You have to understand all that stuff, the principles. If you talk to artists about the principles of art, the principles of getting perspective, it's a dissonance. That's the opposite of harmonious. It's dissonant, right? That's based on mathematical and abstract principles, right? And you need to understand all those things, and it's difficult. Let me tell you another one. In language, the whole question of metaphors. The fog crept in on little cat's feet. That's stupid. That's stupid. Okay? This is stupid, that's stupid, etc., etc. Writing ironies. One of the classic signs that you'd write a friend who had a stroke. First thing I did, and he had vision problems, to test whether his mental capacity was still there, is I told him jokes that were plays on words. Right? A play on words. Okay? And if they don't get it, he got it. Concrete operational kids, they don't get jokes that are plays on words. Retarded people don't get jokes that are plays on words. People are reasoning young children. Concrete, right? There was a famous thing I remember, The Graduate. Did anybody see The Graduate? There's one time where he goes to have his first rendezvous with Mrs. Robinson in a hotel, right? And he goes in and there are all these big parties around. And he said, and the maitre d' one says, "Oh, are you here for an affair?" Right? Right, meaning one of the parties, right? And he's there to start his affair with Mrs. Robinson. Interesting enough, I saw it in Israel. And the word, and so in Hebrew, they just translated it as meaning a party. They translated for one or the other, right? And three of us in the theater burst out laughing, obviously native speakers of English, right? Most people didn't get it. That kind of play on words, you really need to be formal operational to get it. What's so funny? Is he there for a party, right? That kind of stuff. And you can see it a lot. And I'll give you an example. There's this huge, huge debate about whether to teach Huckleberry Finn in our schools, right? Because it uses the one good thing that came out of the OJ trial, the N-word, right? The N-word. By the way, if your desire is to write the great American novel, it's too late. That is the great American novel, okay? Twain was a magnificent writer. It is the great treatise in American literature against prejudice. Uncle Tom's Cabin is a concrete operational treatise against prejudice against black people, right? There's Simon Legree, the evil taskmaster, and he beats on Tom, and Tom runs away, and all this kind of stuff was straight at you. Twain said, after he published Huckleberry Finn, if I had written what I wanted to write, nobody would have published it. So he did it with metaphors, with double entendres, with sarcastic humor, with upside-down stuff, with saying the opposite of what he meant. And it's a brilliant treatise against prejudice, provided that you're formal operational. Has anybody read Huckleberry Finn since he got out of high school? You ought to do it.
I'm working on Dickens.
This time you ought to, what? Say it again? Push it down?
I said I'm working on Dickens.
You're working on Dickens, yeah. Okay. Okay, if you remember, the plot of the stories is that Jim is a slave who's running away. Huck befriends him. And they're going to float down the Mississippi on a raft until they start out from the northern part of the Mississippi. I guess it's in Missouri where there was slavery, right? This is, of course, Turing wrote this after the Civil War, but it doesn't matter. And they're floating down on a raft, and slowly, okay, they're going to float down on the raft until they get to the place where the Ohio River flows into the Mississippi. Then they're going to turn into the Ohio and pole up the Ohio, right? They're going to have to pole up because the current's going the wrong way, into the free states, and Jim will be free. Okay? So Huck is taking care of Jim and getting him to be go away. But of course, it's exactly the opposite. Huck's mother has died. His father, I was just working with a student, high school student. His father is a horrible, monstrous, ugly, evil person. As a matter of fact, his father deserts him. His father's an alcoholic. He deserts him. And he comes back and he sees Huck, and he's enraged that Huck has learned how to read. Right? Huck is a wild child. And Aunt Polly takes him in a little and tells him something. He hooks up with Tom Sawyer, who was more of a regular, middle-class type kid. And he's jealous of him. He's a hateful person. There's a description of what the man looks like, Huck's father, that's clearly a description of his soul. Okay? And what we're going to see is, in fact, it's quite the opposite. Jim is taking care of Huck. Jim runs away. Does anybody remember the story? Nobody remembers, right? Just the story. Why hasn't he run away before? He runs away because they've sold his family. Before that, he tells Huck, I couldn't run away. I had to take care of my family. When they sell his family and he can't get to that, he said, the heck with this, I'm getting out of here. He is a man of uncommon decency, a man of a tremendous responsibility. He realized he has to take responsibility for Huck. The proof of it is what happens is that at one point, when they get to the place where the Ohio runs into the Mississippi, there's a horrible storm, and they pass the Ohio. They pass it, and they're still floating with the current down deeper into the south. Jim doesn't say, hey, I'm out of here, baby. I got to get out of here. He stays with Huck. And all the time that Huck is supposedly taking care of Jim, Jim is taking care of him. And Jim speaks, and Twain writes it in a thick Southern accent. He never tells Huck things directly. He asks him questions. He acts in a way that seems that he's very obsequious and condescending to Huck, who's white and he's not. But it's just the opposite. So at one point, they run into two charlatans who get on the boat. Right? They're two con men. One says he's a king, a European king, and one says he's a duke. The duke and the king. Jim spots them right away. Right? For the liars they are. And he begs Huck in his own way to get rid of them, but he can't say it. But he sees it, and he tries to protect Huck from them. Okay, now of course, and ultimately, through this interaction, Huck goes from being this wild child, and he has interaction with other people too, but to being a decent human being, because he's interacted with Jim. But it's all done with metaphor, with double entendres. I'll say the word if you want to sue me, sue me. Every time he's called nigger Jim, every time he uses that word, that's a hint to you that Jim has just done something wonderful. It's a hint to you that here's an interaction that Huck has had with this human being that he never had with his despicable father, that he never had with anyone else. And Twain turns the term on its head to show what a wonderful person he is. And all the time, Jim, Huckleberry, he's got this knot in his stomach because he's doing something immoral. He's helping a slave run away. But it's obvious with you, this is the moral thing to do. How do you take a man like this and you make him property of someone else? You got to read the book. You cannot understand it unless you understand plays on words, double entendres, sarcasm, metaphors. So my answer about reading the book is if a kid can get that, read the book with a kid. It's a magnificent treatise, right? Jim is one of the most noble characters. He's this simple person, uneducated, and he's one of the most noble characters in literature. He's a magnificent human being. And not because he discovers great things, but because he has this tremendous interpersonal responsibility. At the cost of his own freedom and maybe his own life, he's determined to stick with this kid to take care of him. Even though he never says it, But why is he still floating deeper and deeper and deeper into the South? They even get a flyer at one point about the Duke and the Prince, the Duke and the King convinced him to go to New Orleans, which is the end, right? A slave state. And they're going to do, what are they going to do with Jim to go down the mix? Finally, they get rid of him, and it works out okay. At the end of the book, Tom Sawyer comes, and he's going to help Jim escape. And Tom Sawyer reads these fascinating books, so he's going to dig a tunnel from the cabin, out from the cabin where Jim and Huck are staying, out into the woods. He's going to escape through the cabin. So Jim says to him, well, why can't I just go out the window or go out the door? No, no, no. And he sticks there and he stays with Tom and he goes through all this stuff. Later, he finds out that Tom knew he had already been freed. He doesn't get angry, doesn't get upset. It's another kid he has to take care of. He's playing with him, right? He's taking care of him. He's trying to, because remember, Tom is also an orphan. He's raised by his aunt. So the answer to that question is, you've got to see what the kid can understand. You've got to see what's going on here. You have to look at how people are thinking as to whether they can learn something or not. And of course, all great literature does that. If you read The Red Badge of Courage, I remember my daughter was reading The Red Badge of Courage. The teacher wanted to be sure that the kids had read the book. I forget what the guy's name was, but what was his mother doing when they came to get him in the army? On page 87, what was he doing when the first shot went on here? This is not what literature is about. This is a man's struggle with his soul, a young man's struggle for his soul. What kind of human being is he going to be? Moby Dick. My father read Moby Dick with me in high school again. I couldn't believe it. He said, when I read it, they made him read it in 7th grade. He said to me, it was just a fish story. Now he finally got it. Right? Obsession. Evil. There's one character there was the epitome of evil. Right? Hopeless missions, etc. Go ahead. What do you want to say?
What you were saying about the Red Badge of Courage.
Uh-huh.
You know, I think that's one reason why, when I was growing up, why I did not like literature. But then I graduated with an English degree. Go figure, you know? I don't know.
That's exactly right. That's exactly right. I can figure, because when you were a kid, you were given stuff to do that was too hard for you. That's why push, push, push is no. How many of you remember beginning to hate math in middle school, 6th, 7th, 8th grade? Oh, look at all the hands up, right? Because that's the time of transition from concrete operations to formal operations, and you're asked to do things that are concrete operational, formal operational, you're still concrete operational. For instance, and so what happens is you're given concrete tricks to get you by. Okay, I'll show you for instance here. 3 over 9 equals x over 27. Cross multiply. 9x equals 27. 27 times 3 is 21. Right? Let's make it 81, right? Carry the 2, 81. 9x equals 81. Divide by 9. Divide by 9. X equals 9, right? Cross multiply. Okay? So one time, come back to me. So once, I had one of my doctoral students, he taught math at a community college. He said to me, can you show me why cross multiplication works? Show me the logic behind it. I said, oh, sure. He said, you think you can do it in 10 minutes? I said, sure. 10 minutes are up. He's sitting there smiling, that grin, you know. I said, get away from me, I'll do it. Comes back 45 minutes later, he said, you got it yet? I said, I'm almost done, It took me an hour. I discarded this, I discarded that, I finally got it, and I admit he gave me one little hint. Okay? It's just a trick, just cross multiply. You don't know why it works. Who remembers this one? Who remembers this one? Put the box here. Rate, time, distance, right? The car, the train, and the donkey, right? And the donkey, right? If this is absent, take this and this and do this. If this is empty, do this and do this. Right? Remember all that junk? Come back to me. It's because it's a concretizing something, an abstraction that's hard for you to understand. Yeah, go ahead.
Where I teach, the fourth graders are learning pre-algebra now, and they're having to solve for X in fourth grade.
And I bet they don't get it.
No.
She said, push it down and say it.
No.
No. One of the worst things that we do, they just don't get it. We think, and this is part of the IQ stuff, oh, the earlier you get it, the smarter you are. It's a disaster. Once we did something, there was a school, one of our students, she eventually became the head of the psych department at HCC, but she was a student at the time, and she had a feeling they had a Latin curriculum. It was meant for 7th graders, they were giving it to 4th or 5th graders. Kids couldn't get it to save their lives. Some of them couldn't, and some of them could. Finally, she decided to do this on the basis, I think they were giving it to 6th graders, it was meant for 8th grade, on the basis of their reasoning. She accounted what they call for 60% of the variance. 60% of the differences in scores, whether you were passing or failing, had to do with whether you were whether you could use formal operational reasoning or whether you couldn't. Let me tell you something. If you do an experiment and account for 10% of the variance, you do handsprings, right, and you're delighted forever. We told her, you've ruined yourself. The height of your career is your first experience you ever did. You will never find this again. Basically, for all practical purposes, that was the difference. By pushing kids into things for which they're not ready, I already told you about this, you get a disaster. Here. Didn't I tell you about this book? Come to the Hurried Child. I told you about this already, didn't I? The Hurried Child by David Elkind. Okay? You've got to be careful about this. Okay, come back to me. Let me just say something else. I don't want to pick on David too much today, just a little. Okay? Piaget tells us that, number one, no one is ever completely formal operational in any category. And Werner and Piaget by the end of career also told us, when you're hit with a problem, your first instinct is to be concrete. When you get a problem you don't understand it, your first instinct is to be concrete about it. Okay? There was a person here, by the way, who found people who could not isolate a variable or do combinations, right? They found that half the students, half the entering students at Oklahoma or Oklahoma State University couldn't do it. So he said, I don't believe this. So she took 9-year-olds, 12-year-olds, and 15-year-olds who couldn't isolate a variable and said to them, and they couldn't do it, she said, keep everything the same except the thing you're testing. And then test them one at a time. That's all she said. All of the 15-year-olds were then able to do it. Some of the 12-year-olds and none of the 9-year-olds. They didn't understand what she was talking about. Okay? So you have to be careful here. You have to explain to people the rationale and the reasoning behind what's going on. If they still don't get it, you're dealing with people who are not developmentally ready. That's why those of us, and I'm including myself, who got to hate math, 8th, 7th, 6th, 7th, 8th, 9th, even 10th grade, was difficult. I remember in the geometry book, right, I teach us drawing here, come back to here, a geometry thing on the board, and he goes like this. He says, okay, he draws something like this. He said, okay, this is an isosceles triangle. We said, hey, Mr. Ross, no, it's not that size bigger than this. He said, what's the difference? It's just theoretical. It's just hypothetical. You will notice that all of the geometry books, when they draw a isosceles triangle, they try to get these two sides to look equal. Because it's tough to say, come back to me. Just forget it. What's the difference? What's the difference? Just assume. It's difficult. We're very concrete in our thinking. And all of us have that kind of thing. And as a matter of fact, Piaget talked about the fact that people are concrete in various areas. The last time that I ran into, this is the last time I'll pick on you for the next 10 minutes, okay, into someone who couldn't do this isolating a variable thing, the guy was getting his doctorate in philosophy. He was reading Aristotle, high-level stuff. but he hadn't dealt with physical things like that, in years. And he couldn't do it. I said to him, wait a minute. I'm telling you, this guy was formal operational and a half, right? He was operational. I said, wait a minute, don't you see like 1 and 2, right? And it took me 5 minutes to explain it to him. And they said, oh, I get what you mean. Now I see what you're talking about. So that happens. This is difficult stuff because you're dealing in hypotheticals and abstractions that you don't run into in daily life. Now, let me say one more thing here. Let's see where this goes back to. I told you my stuff got all messed up. Doesn't go back to anywhere. Okay? Okay, let's go back to the PowerPoint. I'm getting there. There we are. Okay. Let's go back to the PowerPoint. For Piaget, okay, stages are divided into schemes. Okay? So here's what he's going to say. Let's go to the tablet if we can. Okay? He's going to say, let's say this is a concrete operational mental structure, okay? But it's going to be divided into schemes. It's going to be divided into schemes of time, of space, of causality, right? Causality, there we go. Of geometry, right? Of quantity. And this will be subdivided into continuous quantity like water and discontinuous quantity like counting how many buttons there are, right? It's going to be divided into all kinds of thinking about different things, relationships. Okay, so come back to me for a second. So okay, come back to me if you can. There are parallel and non-parallel relationships. If A is B's brother, then B is A's brother. But you know that if A is B's, right? No. If A is B's brother, then you know A is B's brother, right? Then you know that B is either A's brother or sister. It could be parallel. Tom and John. Tom is John's brother and John is Tom's brother. But John is Sue's brother, but Sue is John's sister, right? There's a non-parallel relationship. Okay? If Tom is John's son, then John is Tom's father, right? That's a non-parallel relationship, right? All those things you know by your concrete operational reasoning. You understand what I'm saying? Those things are just known. Formal operational is tough. You got to figure it out. You have to practice. But anyway, and Piaget calls. Let's go back to the tablet. Piaget calls these things schemes. A scheme for space, a scheme for causality, a scheme for geometry, a scheme for time. Let's go back to the PowerPoint now. Give him a tough time here. Okay? So he's going to tell you schemes are not collections of knowledge the way schemes are for information processing people. I know if you read an textbook, they'll tell you that, but it's not true. Like a procedural scheme, how to add fractions with unlike denominators. Okay? Or a declarative scheme. Mammal. Oh, I have a scheme for mammal. They're warm-blooded, they have hair or fur, they suckle their young, etc. Rather, for Piaget, a scheme is a way of thinking about a particular aspect of the environment. So you have a concrete operational scheme for causality. You have a concrete operational scheme for time and a pre-operational scheme for space. Piaget calls that décalage. You haven't really you haven't completed the concrete operational stage yet, right? These schemes are ways of thinking, not collections of knowledge. Okay? So come back to me, I'll give you an example. Piaget would say in adding fractions, well, unlike denominators, you have to understand, you have to have a scheme, a way of reasoning that tells you, that gives you an understanding of whole-part relationships. Okay? That 8/8 makes a whole. You have to have an understanding of conversions. that 4/8 is the same as 1/2. So if you're adding a third and a seventh, you can both turn them into 21sts. Does anybody remember? I had a devil of a time with that. I couldn't understand. The thing that I could not understand was how everything can be turned into tenths, right? If you have a fraction that's 1/7, you just divide 1 divided by 7. I could do that, just put the dot and do it, and you can turn it into tenths. How can a 7 be turned into tenths and 9's turned into tenths and 47's? 13 47s, you just divide 13 by 47, you can turn it into tenths, hundreds, you can turn it into a decimal. It just didn't make sense to me when we first started doing that. You have to have an understanding of all those relationships, of the interactions of parts to wholes, of the logic of converting into the, once you have all of converting into a common denominator and how this fraction is equivalent to that fraction, then you can add them. Once you have that, then you can begin to learn meaningfully how to add fractions unlike denominators. Okay? I'll give you another one. When you're multiplying fractions, the term of, when you're using fractions, the term of always means multiplying. What's 1/2 of 4? How much? Push it down. Somebody tell me. What's 1/2 of 4?
2.
Somebody push it down. 2, thank you. So you divided, right?
Yeah.
No, you didn't. Let me show you. Come back to the tablet.
Well, it depends on how you work.
1/2 of means times. Of always means time. That's how you have to do it, right? Most of you still, I admit myself, why 1/3 times 1/9 equals 1/27th, I don't know. How come when you divide, what do? 1/3 divided by 1/9. You flip this one, right? Yeah. 1/3 equals 9 divided by 3 equals 3. Right? I remember when it finally made sense to me. Obviously, there are 3/9 in 3, in a third. 1/9 plus 2/9 plus 3/9 equals 3/9 equals a third. Most of us just do a reverse switch, done. Concrete without understanding the logic of it. And I'll tell you the truth. Come back to me for a second. When I finally began to get the logic of adding and subtracting, multiplying, and dividing fractions, then and only then. How many times we say, oh, wait a minute, when do I get a common denominator? When do I just use it? Wait, when I add, when I subtract, what do I do here? Oh my God, do I find a common denominator or not? Help me, help me. Who went through that? Help me, help me. I'm getting all of these, right? Don't you teach math now? Yeah. I teach language here, see?
Those are the problems that we see in high school mathematics.
Exactly.
Juniors and seniors, that's-
Right, because they don't get the logic of it. And I'm telling you, those juniors and seniors have the capacity for formal operational reasoning. But they're approaching it from a concrete operation, mostly because they've been told to memorize what you do, rather than getting the logic of it, and it takes a while. Every adult is concrete operational in some aspects of his or her life. That's the key. Okay? And ultimately, I'm sure you have those problems. You're the one who's the math teacher. I know one of you, I can remember. Okay? They just don't do it. And you say, try to memorize it. Use some sort of mnemonic trick, some sort of strategy to remember. It doesn't work. They've got to see the logic of it, And you've got to take the time to explain it and to make it clear. How many ninths are there in a third? Don't you see there are 3/9 in a third? 1/9, 2/9, 3/9 makes 1/3. So 1/3 divided by a ninth is going to give you, right? And how many times do you see this? Let's go back one more, right? You get this. The kids freak out. They freak out. All right, I freaked out. So why did you just turn it to this? 1/9 divided by 1/3. What? Is this a division? Remember the first time you were told 1/4 really is 1 divided by 4? Huh? Huh? That's a fraction. This is division. Right? That's a division, not this. Drove you nuts. It's because it's just rote kinds of things. And you have to be very, very careful with it, because adults too, and people with formal operational reasoning can happen. Okay, when we get back from the break, we're going to talk just a little bit about, I've talked a little bit about some of the educational implications here and what kind of Piaget is telling you. All right, I'll see you after the break.